Hi, welcome to Chapter 1 Solutions. I'm Julia. Today's tip comes from Runner's World. You learn your vocabulary words 20% faster after an intense workout rather than an easy one. And that also applies to learning your math formulas. So, when in doubt, work out. We're going to start with number 1. Number 1 tells us that the sum of 5 consecutive integers is 35. And they ask us for the value of the largest integer. So let's say that our first integer of the 5 is x. For consecutive, that means just to add 1. So consecutive integer means to add 1. So the second one is going to be 1 more than the first. The third one is going to be 1 more than the second one. So we'll continue to add 1 for each number until we get to x plus 4, which is our 5th term. And we're asked to find the value of the largest term, so we're asked to find out what x plus 4 is. If you got this one wrong, you might have just solved for x. Okay, so what we have to do is simplify the left side of this equation. We get x plus x plus x plus x plus x. That's 5 x's. And then we add the 1, 2, 3, and 4, which is 10. And that equals 35. Now, if you don't remember how to solve equations, don't worry about it. There's a whole chapter on that. But remember, our goal is to get this value of x by itself. We want to isolate this variable so that we can figure out what x is. So the first thing you want to do is add or subtract anything that's on this term. So we're adding 10, so we get rid of adding 10 by subtracting 10. Whatever you do to one side of your equation, you have to make sure you do it to the other side as well to keep it balanced. So you get 5x equals 25. This 5x means 5 times x. So to undo multiplying by 5, you're going to divide by 5. Again, you have to divide both sides by 5, and you get x equals 5. So, if you got 5 as your final answer, again, you found the smallest value of the 5 integers, and we want the greatest value, so we just plug this 5 in here, and we get 5 plus 4, which is 9, so the answer is 9. Number 2 asks us for the product of 5 consecutive integers, given that the lowest one is less than 0, and the highest one is greater than 0. So that means, since we are doing consecutive numbers, we're going in a row. If one of your numbers is negative, and we don't know what a is, but we know that it's negative, since they are integers and they're consecutive, to go from negatives to the positives, we have to pass through 0. So that means that one of these middle numbers is 0. It doesn't matter which one it is, because you'll recall that if you multiply any number of numbers by 0, then the entire product will be 0. So the answer to number 2 is simply 0. Number 3. Number 3 asks us to determine which of the following, if any, are result in even numbers. Okay? So let's start with this first one. This first one says 2 times x cubed times y to the 5th. The only number that we know is 2. And we're not sure what the rest of this product is. However, whenever you multiply a number by an even number, the entire product is even. So to help you remember that, an even times an even gives you an even, and an even times an odd still gives you an even. So if you can't remember this, because there are several rules like this, simply substitute in 2 even numbers and find out what the product is. And here, take 1 even, like 4, and 1 odd, like 3, and find that product, which is 12. Okay? So this product here is going to be even, again, because 2 is even, so it doesn't matter what the rest of the number is. You will still always get an even product. Okay. Number 2, or part B. So this one is a little bit trickier because we don't actually have a number here to let us know whether we're multiplying by at least one even number. However, if you think about it, x plus x is simply 2x. So 2x is 2 times x, and then we're back to this situation. The 2 is even, so it doesn't matter what x is, we'll still get an even product. So both a and b are even. Okay, c is a little different. You'll notice for c, the one known number is 5 times the product of xy squared. So here we know that if it's odd, which the 5 is, times an even, we will get an even product. However, if this is also odd, we get an odd times an odd is odd. So in this case, we cannot determine whether C is even or not because we're not sure if we're dealing with two odd numbers here or with one odd and one even. So this one is a cannot be determined. And so I'll just write a question mark for shorthand. And then finally, part D, it says 2 raised to the x power. Well, remember that when you are multiplying by a power, this is simply telling you how many times you need to multiply by 2. Okay, so 2 raised to the x. Let's say that x is 1. 2 raised to the first power is 2. If x is 2, 2 squared is 4. If x is 3, 2 cubed is 8. So no matter what, since we're multiplying by 2's, we are going to get an even product. Okay? So A, B, and D are all even. Number 4. Number 4 is our first quantitative comparison question. And so because of that, I'll just give you a quick reminder of the answer choices. So if quantity A is always bigger, and that's your job to determine whether it is or not. If quantity A is always bigger, the answer is A. If quantity B is always bigger, then the answer is B. If the two columns are always equal, then the answer is C. So they have to always be equal, not just under a particular circumstance, but under any circumstance, they have to be the same, then the answer is C. And D is your cannot be determined. So either you have no idea because you're unable to figure it out, or sometimes quantity A is bigger and sometimes quantity B is bigger depending on the scenario. So D is your cannot be determined answer. Okay, so quantity A equals x and quantity B is x to the 5th. Note that we have no information about our variable here. We don't know if x is positive, negative, or 0. So right away we're probably thinking that the answer is going to be D, but let's test a few numbers. So if x is 0, both of our columns have a value of 0. Okay, the same is true if x is 1. If x is greater than 1, however, like 2, then the value of this column is 2 and the value of this column is 32. So right here, we already have enough information to say that the answer is D, because sometimes they're the same and sometimes quantity B is greater. So therefore the answer is D. But I'm going to add one more in here to remind you of when this column could actually be larger than this column. So let's say that the value of x is a decimal between 0 and 1 or a fraction between 0 and 1. So I'm picking 1/2. Remember that when we raise a decimal or fraction between 0 and 1 to a power greater than 1, the number actually gets smaller. Okay? So 1/2 raised to the 5th power is 1 over 32 when this column is 1 over 2. Okay? So this would be 1/2 and this would be 1/32, so column A would be bigger. So overall, our answer is D. Number 5. Number 5 is another quantitative comparison question. This time we're actually given information about our variable. So this tells us that x is less than 0, which means x is a negative number, and we're asked to compare the opposite of the absolute value of x with x itself. So if you don't want to think abstractly, you can simply pick a value for your variable x. So let's say x is negative 3. Any value that meets this condition works. You just have to make sure that you meet the condition. So here x is negative 3. So for column A, that means the opposite of the absolute value of negative 3. And for column B, that simply means negative 3. Okay? And we want to know which one is bigger. So in a situation like this over here, the first thing we want to do is take the absolute value. So the absolute value of negative 3, which again is simply its distance from 0, is 3. And this negative is still here, so we must bring that negative down. So we get negative 3 equals negative 3, and therefore the columns are equal. If you want to know whether this will always be the case, you know that x is going to be the same in both columns, and you just want to know if one column is positive while the other one is negative. Okay? So a regular x is always going to be negative, and then the opposite of the absolute value of x, well, this absolute value of x is going to be positive, and then it's going to turn back into a negative. So both of your columns are negative. Therefore, the answer is C. Number 6, our third quantitative comparison question. Number 6 wants us to compare the number of numbers between 0 and 1 with the number of numbers between 1 and 5. This second, numbers and numbers, is very important, okay? So numbers again means all numbers, not simply integers. So the number of numbers between 0 and 1, if you think about our number line, would be anything that falls in here between 0 and 1. So it could be 1/2, 4/5, 3/7, the square root of 0.3. All of these values are going to fall between 0 and 1, and there are an infinite number of numbers that fall between 0 and 1. Okay? The same is the case for the number of numbers between 1 and 5. If this is 1 and this is 5, not only do we have 2, 3, and 4 that fall in between the numbers, we have 2.5, 3.5, the square root of 11, an infinite number of numbers. So for question 6, the answer is C. The columns are equal. Question 7. Question 7 tells us that Leo and Larry are not morning people and they both like to hit snooze. Okay? Leo's alarm goes off beginning at 7 a.m. and once he hits snooze, the snooze rings his alarm again every 10 minutes. Larry's alarm goes off for the first time at 8 a.m. and his snooze then goes off every 9 minutes. And the question wants us to find out when their alarms go off at the same time, given that they have each hit snooze at least once. So that last part is important. They have to each hit snooze at least once. So you'll notice that under Leo's time, I start at 8 o'clock and then go up in 10-minute increments. I don't need to start at 7 o'clock because Leo's alarm is going off every 10 minutes, so it will go off at 8. And since Larry's doesn't start until 8, they can't overlap before 8 o'clock. Okay? Now some of you may have been tricked and said the answer was 8 because this is the first time their alarms go off at the same time. However, at this point, Larry has not hit snooze yet. So you want to look for the next number that overlaps. So what you can do is the listing method and go all the way out until you find the time where Leo and Larry's alarms go off at the same time. But if you notice, the minutes place here for Leo goes up in multiples of 10, and for Larry goes up in multiples of 9. So what you're looking for is the first common multiple between 9 and 10. In other words, the least common multiple. So you might know right away that the least common multiple is 90, but if you don't, you're going to go back to the method we discussed in the chapter, which means you break down each number into its prime factors, and then you build your least common multiple. So the least common multiple has to have all of the factors of 10, which are 5 and 2, all of the prime factors, that is. And then it also has to have all of the prime factors of 9 that are not already represented down here. If they're already down here, you don't want to add them because then your multiple is too big. You're making it bigger than it needs to be. And we want the smallest one. So in the case of 9, there are no common multiples with 10, so you have to bring down both of the 3's because we need 2 3's in order for our number to be divisible by 9. So 5 times 2 times 3 times 3 is 90. You'll notice that that's just the product of 10 and 9 because in this case, again, they don't have any factors in common, so it's simply multiplying the two together. So 90 minutes after 8 o'clock, when Larry's alarm goes off for the first time, Leo and Larry's alarms will go off simultaneously. Okay? So the answer is 9:30, 90 minutes after 8 o'clock. Number 8. Number 8 asks us for the smallest number greater than 2 that leaves a remainder of 2 when divided by 3, by 6, or by 9. Okay? So this is a little bit complicated. So what we'll do is we'll start off with just finding a number that when divided by 3, it gives us an answer with a remainder of 2. So what we're looking for in this case is a number that is 2 more than a multiple of 3. So let's take 6 for example. 6 is a multiple of 3. 6 divided by 3 is 2 with no remainder, so we want to add 2 to the 6 so that we have 2 left over. Okay? So that number would be 8. 8 divided by 3 is 2 with a remainder of 2. So this is one number that when divided by 3 leaves us with a remainder of 2. However, the question wants it to apply to 3, to 6, and to 9. So we need a number that's 2 more than a multiple of 6 and 2 more than a multiple of 9. Again, they want the smallest such number, which means we have another least common multiple problem. Okay? So we need to find the least common multiple of 9, 6, and 3. You might know right away that that least common multiple is 18, but if not, you break these numbers down into their prime factors and you build your least common multiple. So to be divisible by 9, you need 2 3s in your product. To be divisible by 6, you need 1 2 and 1 3. You'll notice we already have the 3 covered, so we just need to include a 2. And then to be divisible by 3, we simply need a 3, and we've already got that down there. So we multiply our factors together to get 18. So 18 is the least common multiple of 3, 6, and 2. And since we want a remainder of 2, we have to add 2 to that 18. If we don't add anything to the 18, all these numbers will go in perfectly with no remainder. So we want a remainder of 2, so we add 2 to our 18. So our number is 20, and that is the answer. Number 9. Number 9 says if x to the 4th is 81, then what is 2 raised to the 2x power? So I consider this to be an if-then question. For an if-then question, you'll notice that there's something repeated from the first part of the problem to the second part of the problem. And what's repeated is our variable x. So x is the same up here as it is down here because it's within the same problem. So in the if part of the problem, we'll have enough information to figure out what our unknown is. And once you figure out what that unknown is, you simply substitute it here, okay? Because it's the exact same value. So you might know that it's 3 to the 4th that equals 81. So that means x is 3. If you didn't know that 3 to the 4th equals 81, you can play around with it a little bit. So you might say 2 to the 4th. Well, that's 16. Okay? And you can calculate that out if you don't know it off the top of your head. And then you can say 4 to the 4th. And that's 256. Okay? We're looking for 81, which means we need a number bigger than 2 and smaller than 4, and that is 3. Okay? So now that we know that x is 3, we simply substitute it here. So 2 raised to the 2 times 3 power is 2 to the 6th power, which is 64. So our answer then is 64. Number 10. Number 10 is another quantitative comparison question. We're asked to compare 9 to the 14th and 3 to the 28th. Just so you know, since we have numbers here and no variables, the answer can only be A, B, or C. It will never be D, cannot be determined, because we can calculate this value and get an exact value here and an exact value here, so we can always know for sure. So if you ever come across a problem like this and you're unsure how to do it, if you have to take a guess between A, B, and C, never guess D. Just because you don't know how to do it doesn't mean that the answer cannot be determined. Okay? Keep that in mind. But of course, with all our practice, you will be able to get ones like these. So, we're comparing 9 to the 14th to 3 to the 28th. You are not going to want to put 9 in your calculator and multiply it by itself 14 times. So what you're going to do is try to make these look as similar as possible so that you can compare them. Okay? So, your bases are what you want to make identical. You almost always want to break down your bigger base to equal your smaller base. Okay? So you want to break down the bigger one. You'll notice that 9 is simply 3 squared. So if I rewrite 9 as 3 squared and raise that to the 14th power, when I simplify this expression, I get 3 raised to the 28th power. And now you see that column A is the same as column B, so the answer is C for number 10. Number 11. Number 11 wants us to compare 27 to the 8th and 9 to the 14th. So you see that it's a similar problem to number 10. The difference is not just that the bases are different, but that you can't break down 27 easily to 9 raised to some power to make our bases identical. Okay? Because 27 is actually 9 raised to the 1.5 power or raised to the 3/2, and that's a lot more complicated than simply raising it to an integer. So what we want to do instead in this case is break down both of our bases so that they're the same. So you know that 9 is 3 squared, and we're going to raise that to the 14th power over here. And this should give you a clue as to what we can break the 27 down into. So we should be able to break 27 down into 3 raised to some power. So 27 is 3 cubed, and that is still raised to the 8th. So 3 cubed raised to the 8th is 3 to the 24th, and 3 squared raised to the 14th, as we said in the last problem, is 3 to the 28th. So for number 11, the answer is B. So that includes our practice problems from this chapter. What I advise you to do is go to the study plan at the beginning of the book and look at the suggested problems to be completed in the official guide. So at this point, the problems we gave you in that study plan that are in the official guide, you should be able to handle hopefully with ease. Okay? See you back next time.